any inductance, resistance, capacitance and L, RLC. They're calling as RLC. Resistance, inductance and capacitance. These are the basic three elements. Wherever you go, you will have come across this kind of components. And next, that is, we are talking about the circuit theory. Circuit theory, if you see, circuit analysis. We have studied about all the how to analyze using the theorems. I think you have studied about Sudhar and Sham. Circuit theory, but circuit theory studied, no? What do you follow? Circuit theory. I don't know. Maybe Sudhar and Sham book is available and the HIGHTECH book is available. So that kind of book you see, all theorems you studied. Starting from Kirchhoff's current law and voltage law. That is the first law. Kirchhoff's current law and voltage law. That is the basic laws. Wherever, if you want to analyze any circuits, we need these laws. Kirchhoff's voltage and current law. In how, see, each subject will follow the other. One subject, if you are studying any subject, it is needed for studying the next subject. Circuit theory, if you study circuit theory thoroughly, then EC1 will be very easy for you. Okay. I think EC1 is easy for you, no? Is it difficult or easy? Difficult, boys? Sorry, yeah. Is it difficult? Yeah, difficult. You say difficult. Girls more in this class. You are feeling sometimes circuits are difficult or easy? Huh? So, see, just to say what is wrong. So I came here to share what is things is going on in the world. Subject anybody can teach you. Okay? Subject wise anybody can teach and you can learn by yourself. Everything is there in the book. You open the book, it is there. Just go to the Google search, whatever circuits you need. Basically from, if you type devices, lot of numbers will come. I want to learn about what is transistors. What is that? Transistors. Why we want to use these transistors? If you go and search in Google, lot of transistors comes. So we have to see which we have to applicable for us. NPN transistor, PNP, or vacuum triode. Before that, in transistors, these are the evolution of transistors. Starting from ICs. First IC, small scale integration. They manufacture the IC. Then medium scale integration. Now, then the generation changed to large scale integration. Now we are in very large scale integration, ultra large scale integration, and giga large scale integration. Electronics the manager. Before that, we will have a small IC device is there, which if you see Arfam IC 741, like that the design firstly with some kind of transistors and they manufacture with the size will be very large. So due to the inversions in the transistors, now we are talking about we can fabricate millions of transistors. So we can fabricate millions of transistors, okay, in a small hair dia. You see the hair will have made of dia area will be there. In that we can manufacture millions of transistors. The kind of technology we are going. Talking about 180 nanometer technology or 120 nanometer technology, okay, and 0.8 nanometer technology. So now you know this is the electronics for the inventions. Okay, so we are fabricating a million of transistors in the single die area of the human hair. So if you see in the processor, you take this processor, inside this processor. Okay, this is not a CPU now. So inside that, if you see, it has only the ICs will be there. Talking about 20M2 processor, 20M4 processor, or what is the I4 I-core processor and what is the processor calling? Quad 2 or like that. Quad core are. So lot of things nothing but there are so many processors will be there. There is single core processor and multi-core processor. Okay. So it depends. See, they are manufacturing that kind of ICs, transistors in a circuit. So why I am trying to say means without this electronic circuits, we can't able to design such a analysis in the IC fabrication. Finally, if you see anything you want to design, for example, if you want to do in the lab, I think you will do in the lab as you will do oscillators or fixed bias circuits. And what are doing in the lab? Experiments you are doing in the lab. That is we can say that is called as the practically you are doing it. See, what type of experiment you are seeing? Common emitter, bro. Different amplifiers, different amplifiers. Darling amplifiers. So like that, we can design an oscillator also. You can design see whatever you are doing in the lab, you can design as a oscillators. That is the application. That is the idea. You want to design a oscillators which will produce an oscillation for a particular frequencies. It will produce the oscillations for I want to for 10 megahertz I should come. So like that you are designing. So once you design for such application, so that you have to write the program for that. Then finally you have to implement in the IC. Everything finally if you see goes to only for IC fabrication. Your idea, you are having some idea that is implemented into design. Finally, that idea is implemented in your design. There and all, if you see, we know where the fault will occurs. So small circuit breadboard you are doing the experiment the breadboard. Any fault occurs, we can easily find out where the fault occurs. Why you are not getting the proper output. So like that, in electronic circuits, so you have to study the analysis thoroughly. Because if you feel it's a difficult subject in first term itself, we can't study for higher semesters. So this is the base. Second, third semester is the base where you should study thoroughly about electronics. Since you are an electronics student, no, you are a electronics and communication students. You must study about transistors and its applications and why we want to, how to design a circuit. The application, if you take any application, we can't limit the application of electronics. You take anything, any product in your home. Okay? So here also you see a lot of electronic components is there. AC, lighter, okay? The audio amplifier, this is an amplifier. Mic. So mic is an amplifier. Basic purpose of a transistor is amplification. So basic purpose of a transistor is amplification. My signal is to be amplified. Now I am speaking this like this. If I hear this hand mic, then obviously my signal is amplified to 5 to 10 times. So this is small class. I am not using the 4. That is what is called the cordless phone. This is a cordless mic. Phone la mic. This is a mic where my frequencies will be in some range. So it's audible for you. It is not so easy to design. You go and take the circuit. The little of evening go and search how to design a cordless phone. How to design this cordless phone. How to design this cordless phone. See, my signal is amplified to you throughout the speakers. If you see the circuit will be very complex. But transistor circuit resistance put it is not like a small rectifier. I studied it. I think you have studied about rectifiers. Rectifiers will be very small and easy also. So if you apply positive output voltage, you will get a positive wave. If you apply negative voltage, you will get a negative voltage. And we have to calculate what is the amplitude and what is the peak to peak value and what is the root mean square value and RMS value, like that, and what is the equal factor of that. Like the analysis or an ordinary operational amplifier itself, we need to analyze what is the ripple value, how to reduce the ripple present in the output. There is a noise present in the output. So in this first unit, they are discussing about what is transistors. I think operation is not just for operational transistor. No, only analysis. So they are saying about biasing the first unit deals with the biasing of transistors. So biasing, why you want to study electronics? Application, we can't limit the applications. Starting from nowadays, everything is automation. They are going for automated world. So AC, if you set the temperature, automatically there is a regulator is there. The option notified. We should shut down the voltage. Only the cooling will be there. Whenever the decreases, that is increase in the voltage, it goes 28. 1 second the compressor should on. Like that, we are designing a circuit such a way that is the electronic circuit. A small example I am saying. Wherever you go in your home, you take any applications, take a watch, there will be some digital watch. Nowadays, everything is digitized. On the digital signal processing. Talking about the digital signal processing, converting the analog signal into digital signals. But the real life, what we need? Real life, real world application, what we need? Digital, okay, digital, using digital. Here the answer is there. See, I am converting the signal by using a AD converter. So analog to digital converters. Once again, we are converting the signal to digital analog. So real the application to see, everything will be analog values. Digital also okay. So real application, take image application, or if you take any video compression application or anything you need, the real output will be only the analog, not digital. That's only we are having input level having the AD converters and output level having D2A converters. Digital to analog. If you want to transmit a signal, phone I want to have a signal, transmit data. So real world is nothing but only analog values. So electronics, what the fundamental what you are going to study here is very much needed for your future. Third year, final year, or MS coding nursery, we go to ME. Okay. So this analysis will come for you. So only in India we are teaching, okay, this is a fixed bias circuit. You have to learn like this. If you go for upper and down, it is not like that. You have to learn. You have to design the application is that they will teach you. So you have to learn by yourself. You can't meet the professor like this. Okay. So we have to get an appointment with the professor. I have some doubts. You have to write the doubts. This is a doubt for me. And he will come and explain them. He may give the appointment or he will give the answers in the net itself. So what book you are following? The alternate circuits one. Which book? Bakshila and Padikar. Okay? Then electrons will be difficult for you only. So Bakshila, if you see, then you can't learn what is electronics. Okay? So electronics, particular. So I think the textbook they have given Sarah Smith for you. Sarah Smith, I don't know. Or I think maybe they have given Milman Halkis. I don't know which book they have given from the syllabus. Syllabus na pathina. In syllabus they will give textbook to Ala Kandipa, they will not give Bakshi, now I think it is not there. There will be Sarah Smith book. Microelectronics by Sarah Smith book. There if you study from starting from first page, that is the syllabus maybe chapter 1, chapter 2, chapter 3. Then if you study 5 chapters in that book, definitely easy one will be easy for you. If you study Bakshi and it will be difficult for you. He will give lot of equation and theory. You can't remind all the theories for exam. Make it analysis. It's not like prestige and all. Then once again you will read and forget. Exam point of view, okay, they will ask voltage biasing and some problem. You write, okay, this is a separate equivalent circuit, and I can find what is IC, what is R1, R2, and finally I can find what is the output voltage. Don't exam. I'm not saying you will fail the exam. You study Bakshi book, I think you will not fail the exam. Okay? Maybe somewhat you will read and you will omit it and you will get cleared. Maybe 60 to 70 marks, somebody will get 80 to 80 also. But okay, so you have to study some standard. See, you can refer. Okay, Bakshi okay. I'm not saying I should not see that book. I'm not saying it's the worst book. I'm not saying it is a good book. But if you want to study electronics, means you have to study some standard books which is available in your library or you can buy. Sarah Smith also, I think it is a good book. Or Millman Halkis book. Millman Halkis by Electronic Devices. Integrated Electronics. Integrated Electronics by Millman and Halkis. Sarah Smith, I think it is given for you. Syllabus is not Neiman, yeah. Neiman. That is also a good book. For our student, electronic circuits, we are giving Sarah Smith. So for you, it is given as Donald A. I think it is. I think, see, it is given as a reference book. Sarah Smith. It is given as the reference. This book is Donald A. Neiman. And the reference of it is given as Sarah Smith. From that book, if you study or 5 chapters, then coming chapters will be easy for you. That's the concept. You have to learn that sort of theory. The book will be size, it will be like this. But you should not be afraid. You have to take that book and we have to learn from, okay, this gives us about transistors. If I want to learn transistors, I must know the operation of diode first. Must know the operation of diodes. Because each transistor is a combination of diodes only. So if you take any rectifier, diode put. The diode operation you have to study thoroughly. Then you are going for transistors. See, now if you take, nowadays we think match market match. So Eden Garden is the, what is Eden Garden ground? It is the largest ground in India. Not only in India, I think in Asia also. It is the largest ground. In that ground, you take an ant. Ant. Okay? You take one ant like that. Like that, you fill that full of ant of that ground. That much of IC can be manufactured in a small area. Millions of transistors are fabricating in a small area. You think how much complexity is there? How the computation will occur? It should do all digital operations. And okay, flip-flops shut down, registers, counters, learner circuits. So in each process, I want to, this is communication. Communication. Take wireless communication. Take a mobile application. See how much of application is there in a mobile phone. You see, we can hear music. We can chat with our friends. We can download movies. You can watch video on demand. Live you can watch. Now 4G. You are going for 4G. This is the wireless communication. Lot of job is there for you as a PG student. Lot of opening is there. After 2 years you see lot of jobs only for PG students. Take a survey and see everywhere we need electronics engineers. You take automobile, mechatronics. Nothing like mechatronics. It's a combination of electronics and mechanical. Industry needs a people. Industry will not take 2 people. I want to take only one, which I have to pay the money. He must able to tell about electronics and mechanical. Okay, so this is an interdisciplinary branch. Why it is? Because electronics application on water trigger. You take any Audi car, BMW ar, any car you take. You take any car which cost about 15 lakhs. Okay, everything is automated. GPS, okay, airbag, how to control the fuel efficiency. Microcontroller and microprocessor. They'll put the multiprocessor coding point. Okay, so the fuel efficiency how it takes place. And that is the design of your role. Just I will see circuit like this, I'll go on like that, and that's not a job. How to design a real world, what's a need. That is the role of it. So you students, just to go and study the Nieman book. Whatever book is given, and take go to the library and buy that book at least. This cost only 200 rupees, I think so. 250 cost. Okay? Just to study that book so that it will be easy for you when you go for next semesters. Or next semesters, analysis. So here you see, you tell me, now we'll come about the syllabus. So any doubt you want to ask? No, electronics. Without electronics we can't live. The TV is bigger. Now you take any TV. Okay, we are going for. Before that, while I am like a student, the TV is like big size. No TV is very cost pathingala. It will be very. While I am studying my +2 and B, I am not having my TV in my house. That time the TV cost about 10,000 rupees. Okay. By that time, Bush TV will come like this big size or Onida. We have no that 10,000 is very high amount that time, and the size is very big. Okay. So we will buy the TV and we will see some channels around. Now if you take channel, how many channels coming? We can't able to see any channel. They we can't see one channel for 10 minutes. Maybe somebody will see. Most of the people will not see the same channel for another 10 minutes. See, why I am saying means that much of technology creature, electronics. Okay. So now the size is very big. So flat TV, LED one, like this screen you can mark it. Like this, if you go any home, we are having big TV only, not small TV. Just go and see your friend's house. They'll have only the flat TV, which size very big. To go and buy, if anybody want to go and buy means, they're going to buy only a big TV. Why you want to go and buy the large screen? The cost is very less. Comparatively, the cost is very less. If you take 40 inches TV is only 20,000 means, maybe 60 inches only 30,000. So the cost has been reduced because of the technology. So this analysis of electronics in your syllabus is that is biasing. So what is biasing? I think you studied biasing. First you biasing. Yeah, now we'll see about some syllabus. I think 3 chapters were studied. Okay. Then we are going 4th is the high frequency analysis, and 5th is IC MOSFET amplifiers. Yeah. So we'll discuss about all the topic. Just to discuss. Tell me why we want to bias a transistors. I think you are doing in the lab. What is in biasing? What is in biasing? See, you studied no. See, just I came to represent. In the exam point of view, all units carries equal marks. You take any, you take all the previous question papers. You go, please go to the library, take the previous year question papers. Okay? You see what are the maximum part A question can be asked in first unit. What are the maximum? If you only repeat that question, they will ask what is the need for biasing, or what is the application of biasing, or they'll use some bias circuit, but fixed bias. They'll ask to find out any one of the values, whether you want to find out the RE value or the RB value like that. This is the maximum question they will have, and mostly all are repeated in the examination. So first thing is, if you feel as a difficult means, you go to the library and take some question papers which is asked in previous years. Don't think that easy one, LMS same syllabus. Last I am saying from last 8 years, the same syllabus followed. Only the regulation is changed. Regulation is changed. So in the question paper eduthalum biasing irukum, and biasing will be there, and that is transistors. FET irukum, BJT irukum, MOSFET irukum, like that. So you tell me what is the need for biasing? First you biasing. What is I am asking, what is biasing? Yeah, to make a transistors in a particular region. Yeah, good. To make a transistors in a particular region. Why? Why? Tell me. No. Okay, she told, I asked what is biasing means. So biasing நம்ம எதுக்கு பண்றோம்? What is the need for biasing? I will ask like the question like this. So she told to make the device means it is a combination of resistors and capacitors. It may be any of the components. Okay. So she told to operate in a particular region. Yeah, that is the transistor is operating in the active region. You know, there are 3 regions is there. They will ask in 2 marks also. Cutoff region, saturation and active region. So biasing, she told, to operate in a particular region means that is the active region. Only in the active region the transistors is, we have to bias a transistors. Active region, you know, in transistors they are in 2 junctions. It is a combination of NPN transistors. If you take any NPN transistors, they are in 2 junctions. One is the emitter junction and that is the collector junction. So if you bias, so biasing means we are operating at transistors. We are operating at transistors in a active mode. That is, we are so biasing is nothing but we are fixing an operating point. Q point above. Nothing left. That is called as what is operating point or Q point or Q-shunt point. So any device, you are manufacturing panalo, analysis panalo, it is any device you are taking and analysis circuit means you should bias the transistors. That is, we have to analyze the circuit with DC operating conditions. Okay. So DC operating means without applying AC voltage, they are applying the DC voltage and fixing the 2 points. Okay. To IC versus like Y-axis axis and on the VC. So biasing this slide. Biasing. This is the VDD and biasing. So biasing is nothing but fixing the Q point so that the transistors will operate in the active region. As I told you, the main purpose of a transistor is amplification. The signal amplify agano. Okay. If you take any circuits, okay, you know, lot of loss will be there. Okay. So my signal, if I push this girl, okay, I push this girl means the she push the next girl. It should become like this exact of my last la. It will take some kind of time is there. Time delay will be there. That is a delay. My signal immediate up. It is like a lightning madri. Then I have to push forcefully so that you go like this faster. So like that, the signals should be amplified without loss. Loss will put If I giving 5 volt amplitude output I need only 5. I need 5 voltage. There should be no loss. Maybe 4.9 or 4.8 up to 4.5 is acceptable. Below 4 means it is not acceptable. So the transistors, if you are not biasing at transistors, it is not, the signal is not amplified. Amplification process nadakadu. Okay? That is the basic purpose of biasing. So biasing pannada in the device on the, not only for transistors. If you take any FET or any MOSFET or any device, in the device panalo, you should bias the transistor. That's the only they given biasing is the question. So fixing the Q point. See the diagram. See that so that you understand. So these are different types of BJT. You know what is the common emitter. So coming to the combination of transistors, till now, okay, only the technology changed. Transistor which today we are going for FET, JFET, MOSFET. Okay. That you study in for third year VLSI படிப்பீங்க. Very large scale integration. So we are having 3 combinations. One is common emitter, common base, and common factors. So each one has some advantage and some disadvantage. So common emitter is broadly used in electronic circuits. Okay. Common emitter we are using mainly. So common factor, you know, for high input impedance we are using. And this is the symbols of a BJT. One is the NPN, as I told you, there are 2 PN junctions. One is between the base and the emitter, other is between the base and the collector. Okay, there are you see diagram here. There are very confused in the exam. Draw the symbol of the transistors. Okay, most of the students will not draw properly. So NPN person now PNP put PNP person NPN they will draw for now. See the direction you must draw correctly. Another mark. Okay. Draw the symbol of a FET and JFET. So like that, the directions other mukya they will see that key points. Summa reporter they will not give. See, it is not theory. Electronic circuits not theory keka matanga. Example pathina, they will not ask any theory. You should draw the circuit and analysis. Theory vanda mulakku da. If you see almost all syllabus you see, there will be no theory for you. Like differential amplifier da analysis da, biasing amplifier analysis da, class A, class B amplifiers parchalo, it is only analysis, and IC MOSFET amplifiers. All the analysis are. You have to draw the PNMOS, okay, NMOS and PMOS, and we have to draw the with load, depletion load, enhancement load. Okay. So that draw the circuit and apply the Kirchhoff's law. Apply the Kirchhoff's law and find out whatever we need. Any doubt? Any doubt? Just you want to ask? Tell me. Boys, any doubt? Just non-electronics, future, as I told you, lot of companies investing in wireless communication, mobile communication. Job very good. Only thing is, you have to learn. You have to learn. Asal Pradeep. So why I am trying to say means, see everywhere the signal, see the address is a closed door. But the signal is coming to my mobile phones. I think you said about early effect. Okay? They will ask what is avalanche effect, early effect, wherever you go they will ask. So analyze and study. So now this is a symbol of the NPN and PNP. See, now last 4 decades you see, we are discussing about diodes transistor. Next generation we are not going to use this kind of device. Why? We go next to this generation. We are not going to use the components like this. Okay? Why? Because whatever the technology can be shrinking the device. The channel the voltage and the current depending upon the channel only. You know, I think you studied about the Dept. Device for singular junction field effect transistors. We are forming the channel. So depending upon the channel only, the current flow will be in the circuit. If there is no channel, there will be no current flow in circuit. So next generation we are going for carbon nanotubes. We have devices I told you, human hair dialer. Take human hair, the dialer, and the dialer we can manufacture million transistors. Our area we minimized. Human hair and parting of dialer, 50 or and the dialer should take like this round dialer. It will be like a die will be there. In that we can fabricate more number of transistors in that. So our device points. We can't be able to shrink the device. So the next generation will be using the carbon nanotubes. So angala the bubbles. It's like bubbles, air crack. Wherever the air is coming, there you can place the transistors. The technology is going next generation. The technology is like that. And they are going for nano wires. Nano weight is 10 power minus 9. They are going for nano devices, nano wire devices. So nano weight 10 power minus 9. All the devices what you are going to study is going to be replaced by a nano wires. Okay. So So you study in Neiman book so that electronic circuits will be easy. But initially it will be difficult for you only. While starting, it will be difficult for you. If you are going on studying means it will be easy and it will be useful for your gate. If you are going for after completing your BTech, BE, definitely somebody will want to study ME, somebody want to go to IIT, somebody want to go to MS in abroad to good study. There and if you go with this knowledge of studying blockchain, definitely will not help you. Okay. So this kind of books you have to study. Then Cesar Smith Donald D. This is the operation done there for you. And this is the BJT, the input channels, output channel operations. IC is, IC is the pure types of IP. The formula is the basic formula to remember. So color current will be pure types of IP. I think in the analysis of fixed bias, we are applying only Kirchhoff's law, Kirchhoff's current law and voltage law. Applying the Kirchhoff's law at the input loop and applying Kirchhoff's law at the output loop. And finding the base current at VCE. Applying the IB base current at VCE or R1, R2 values. Whatever we need, we can be able to find out. Whichever you want, you can find out. So this is the VELTECH system of this is the biasing. Okay. So this biasing, as I told, amplifier we are having AC analysis and DC analysis. This is the main part. We take any circuits. One is DC analysis, AC analysis. DC means without applying AC voltage, how the circuit will behave. After applying the AC voltage, how the circuit will. That's why only we are having two. In the lab, we are having two power supply units. Okay. So the choice of DC level will affect the AC reference. DC will affect it will affect the AC. So DC must be fixed. That is only fixing the Q point. Q point must be fixed at the center of the load line. Okay. As I told, no. So diagram so that you can understand. Okay. So the DC levels are controlled by various factors That is the wide ranging of operating points. Input la IC, this is the your output la VCE. Different kind of input voltage will apply, base current. Again we will have different kinds of, we will have more number of operating points. So that analysis is very much important. And the biasing is, three types of biasing is there. One is fixed bias, called base bias, and voltage to divider bias. Example main they will ask voltage divider biasing. 80% question papers will be problem category, they will ask problem. They will ask problem or derivations. Circuit theory for the example. They will ask only problem and derivations. Don't write more theory and lose the marks. Write the apply law and write the equations. So if you see the biasing, the basic function of a device max amplification, the process of rising the strength of the big signal, the process of rising the strength of the big signal without changing the shape is for faithful amplification. Without changing, I can raise the signal strength without changing the shape. If I apply a sine signal, it is only a sine output. And the square or my signal should not disturb. That's the meaning. So peak to peak 5 volt output 5 volt. So you know the difference between, I think, similarly for faithful amplification we need the two junction terminal. One is the emitter base junction that should be in forward bias mode. Okay. And collector base junction must be in reverse bias mode. Emitter and base must be in the forward bias and collector and base must be in the reverse bias modes. That only the transistors will operate as an amplifier. The amplifier is single stage amplifier, multi-stage amplifier. If I have only single device, it is single stage. If I have so many stages, it has multi-stage. See, these are signal times now. One signal here, one signal here, one signal here. So now I am saying something. Some transistors will pick up very fast. She knows everything. She's learned. Somebody will not learn. So that transistor will not pick up. It is, see, industry needs only smart systems. System means it is a combination of blocks. These are physical systems, the classrooms. This is the physical system. Student is there, chat is there, light is there. I am delivering the input. I am the input and you are the response. How fast you are able to tell, okay, that is very fast, I will follow it together. Okay? This is why I know. Somebody will be very smart. If you know the fundamentals, I will skip and I will go for next topic. Okay? So now if you see, that is a smart system. You can say that is called as smart system. Okay, the system we are having smart and sluggish system. Okay. The smart means whatever that I am going to try to say, you must know that. Okay, you imagine. Electron is now, it is nothing but electrons and holes now. It is started discussing about the electrons and holes. The electrons and holes will play a major role in your design. So bipolar means the current is flowing combination of electrons and holes. Okay. Okay, transistors you know. What is going for need for going perspective? I'll put a question like this. Okay, biasing you know. It is fixed bias, voltage bias and connected to base bias. Fixed bias, connected to base bias and voltage bias. Okay, we can design any application using transistors. Why we are going for FET amplifiers? Next class, next year is MOSFET, MOSFET IC amplifiers, MOSFET amplifiers. Why you want to study MOSFET? So MOSFET means it is a version of FET. FET is classified into JFET and MOSFET. JFET another junction field effect transistor. MOSFET means metal oxide field effect transistors. Yeah, you're good. So JFET la we are talking about N channel and P channel FET. N channel and P channel. Similarly in MOSFET, where are we? Yeah, NMOS, PMOS is the general classification. Depletion type and enhancement type. What depletion type? If apply the, tell me, no problem. Tell me naturally. Sorry, huh? Yeah, if you apply the voltage, but negative voltage means it is a depletion mode. If you apply, depending upon the voltage, we can at the input. What voltage we are going to apply at the input? If you apply enhancing the enhancement transistors, if you apply positive voltage, it is enhancement type. If you apply negative voltage, it is a depletion type MOSFET. So MOSFET is mainly classified into two types. One is depletion type, other is the enhancement type. It is further divided into N channel and P channel. So you tell me, I put the question like this. Why, see, why we want to go for FET? FET means JFET, MOSFET, NMOS, PMOS, tell me. Interest what use of that? High, yeah, high input impedance, correct? High input impedance, correct?